diameter the press would be. And then as we get into compression stages, notice that shaft tapering up to a larger diameter. That's the configuration we have in the 6-inch test press. Another thing, this flighting comes along here and it stops. There's a gap right there, and then the flighting starts again, stops there, and here's another gap. In these gaps we have resistor teeth. So this press has first stage of compression, second stage, third stage, the third tooth, fourth stage, fourth tooth, and finally a fifth stage of compression. Anyway, all the Vincent presses have that feature, the interrupted flight. Almost all Vincent presses use that feature. It prevents co-rotation. It was patented originally for brewer's slops, is the word in the patent, and that's just about what we're going to be running today. For comparison purposes, here's the screw without the tapered section. You see the inlet hopper area. Oops, first stage of compression, second stage, third stage. Notice that shaft diameter remains constant. That wouldn't be as effective in the spent stillage that we're going to be running today. This press only has only 3 stages of compression, but you see how we've tapered up the shaft. But notice the resistor teeth. There's a tooth, another tooth, and a third tooth for 3 stages of compression. The press we're running, a CP6, has 5 stages of compression. Here's an unusual view where you can see a press with 4 stages of compression, and the screen. There's this wedge wire screen with those slots, and this is, my guess is 15 thousandths of an inch. So we're running 1/2 of the screen in one size and the other side the other size. Yeah, I'm standing on the screw that goes in this particular press. These are flights that are used to make the screws. Here's more flights. These are all stainless steel, and goodness knows we have oodles of flights. We're in the screw department. There's a workstation where they're welding flights onto a shaft, getting another one to get ready to get started, another 2 more trying to get started. We're running this shop 24 hours a day, 7 days a week. I took off Mother's Day yesterday. I think we'll take off Memorial Day. But anyway, screw department is being pushed. I'm back in the test area. I see Bill is agitating our sample. Air agitation, huh?
Trying to.
Trying to.
Put very much to it. It's all over the place.
Yeah. I'll catch the cone later on. Yeah, Bill's going to pour some material in, and coming right through that screen, I expect it to blind over, and as soon as I see something coming out here that's sloshing already, I'll close this cone. I've got it set at a fairly low pressure. Anyway, this cone is now shut, and we're getting a lot of water out. Second 5-gallon pail going in already. Filled up. And you see, it looks to me like, hard to say if we're getting more off this side or this side. Both about the same. Flow is not going anywhere. We've blinded the screen, and which is a typical problem on stillage. I have to give this one some thought, see what we do. Okay, we've got some material on the inlet hopper, getting some dewatering. In a few seconds, that screw you see there is going to stop, and the press is going to run backwards. There it stopped, and the screw ramps up to 120 hertz for about 5 seconds. When we go backwards, we're wiping the screen clear with the material that's in there, we get a heavier flow. The screw is stopped and now it's started going forward again, and we will resume at a little better flow than you saw that we had a little bit ago. So we have programmed the VFD to go forward for almost a minute at 10 RPM, and then it backs up at 40 RPM for just about 3 seconds, I think it's supposed to be. We've got a real quick ramp up and ramp down, 1 second. And so the press can operate forever this way without burning up the motor gearbox, wiping the screen clear. The other thing we're going to do, the capacity has got to be small. We're just not bringing down that inlet hopper level. We still haven't started to make a cake, so I'm going to let this, I'm going to have to let it run for a while till we get some sort of normal operation. Now what we're going to do is see if wrapping the screen will increase the flow of press liquor. That is, if the screen is blinded, we're wondering if, hang on, because here we go. This is an oversized regulator. Yeah, give it a shot, David. Jesus. Oh my God. Ha! Before I forget, this is the force side of the screen, and notice we're getting, at this end of the press, more solids coming through. And on this side over here, where we have this 12 to 15 thousandths of an inch slot width, I'm not doing anything here. I'm finally getting some cake to start coming out of this press. Not enough to start falling on the ground yet. We dropped a little cake down there, but we've got it in operation. We're still running forward about 1 minute, then we back up for 1001, 1002, 1003. We reset the ramp up and ramp down speeds for a half a second each, wasting as little time as possible on this reverse motion. We just started going forward. It's going to take a while for the liquid to pack in there again, the solids to pack in there. I expect to see it pick up a little on the dewatering as we go into this 45-second cycle. Have to watch how that flow goes, see if we want to stretch that cycle out. Okay, another observation. All of the press liquor is coming out on the other side of the screen. You don't see any liquid flowing down here. And what flow we have is coming out this side of the screen. Tells us something about slot width. I'm gradually making some cake, but we've been running a time test. That's 2 minutes, and I barely have a gallon in there. We're not in the ballpark. There's a reverse cycle on this thing, but we're not in the ballpark. The auto reversing mode on the VFD, I think I'll unprogram that and just go constant forward at a steady RPM. We're going to change that. Okay, running a time test with the wrapper. We set it at 60 psi. We were down at 30. We're going forward only, 10 RPM. Cake coming out. Oh, if I grab some of this cake and squeeze it in my hand, I can't even get a film of water. This stuff is as dry as you'll ever get out of a screw press, unless you cook it with friction. We don't want to do that. So we're making dry cake. Fairly decent. Well, I got about 2 gallons there in 2 minutes. So I'm doing 1 GPM, 500 pounds an hour on a press that should do double, triple that. Not bad on this particular material, especially since I'm only operating with one screen. This one is definitely blinded over and not working at all. That is, I look along here and I don't see any water coming down along this lower flange of the screen. It's all coming from the other side of the press. Level in the inlet hopper. You can almost see it going down, not quite. Yep, it's going down. Wrapper, we set it on a timer over here to come on very briefly every minute or two. How about that? Got something that's sort of working here. Okay, I'm going to catch this when the wrapper comes on. Apparently comes on every half a minute. Short burst. Don't see much change. I'll try running without it. Maybe if we've got the press filled up, it's operating. Not likely. Okay, I tried it without the wrapper for a while, and the flow definitely started diminishing. The wrapper does seem to sustain a flow of press liquor through the screen. Okay, we've pulled the screens off. Go ahead and knock some of the material off there. There you can see our tapered shaft. The lights get shorter. What we're doing is we're replacing that screen that was blinded over with the blind slots with one with wider slots. We're cleaning it out so that we don't have any material pinched between the resistor bar and the screen. That being the resistor bar, the thing with the bolt holes. Okay, on that first test we ran, we got 660 pounds an hour. That was 60 pounds of cake and 600 pounds of pressed liquor. The cake was coming out so extremely dry. We'll run a moisture test on it, but since I couldn't get a film of water to squeeze between my fingers, I've upped the speed of the screw from 10 RPM to 20. That is, I was getting that very dry cake because of the severe taper in the screw and the low RPM of the screw. So by doubling the speed of the screw, maybe the cake will come out a little wetter, and hopefully I'll get more throughput capacity than that 660 pounds per hour. Let me correct those numbers on that test. We had 92 pounds an hour of, whoops, I gotta back off here. Okay, that one, test was longer than I thought. But anyway, 55 pounds an hour of this press cake, 55 pounds an hour, and pressed liquor, 330 pounds per hour. Grand total, 385 pounds an hour in a press that should be doing a lot more than that. What we're running right now is the material that was wrapped around the screw that we scraped off when we replaced the screen. Notice I'm getting quite a flow of press liquor from this side of the press, which I was getting zero before. We'll see what happens when it stabilizes. Both screens are about the same slot width. Third variable besides the taper of the screw and the RPM of the screw is the pressure on this discharge cone. I'm at bare minimum. So instead of doubling the speed of the screw, if I would say running at 60 psi, I would have cut it down to 20. But since I'm at bare minimum air pressure on these two air cylinders pushing this cone shut, that's why I had to double the speed of the screw. Looking good. Once we get some of the fresh material going through here, we'll start another time test. Okay, we've started a second time test. This one at 20 RPM. We've not turned on the wrapper. We're getting a strong flow of press liquor, as you can see. Working. This is material out of our blue drum that was shipped to us. We'll see if it keeps working without the wrapper. We're 40 seconds into our time test. What is most likely going on here? Why hasn't the screen blinded? Why is it working so well? It isn't that we changed the screen. It isn't that we changed the air pressure. It isn't that we changed the RPM of the screw. It isn't that we're reversing. It isn't the wrapper. We're near the bottom of the blue bucket, and we're getting thicker material, which tells us a pre-thickener, a side hill screen or a DSM parabolic screen, whatever you call it, would be of value. We had trouble on the very dilute flow, and this stuff that is settled out just by gravity, not a whole lot, is working a lot better.